Hubble and Webb Space Telescopes. Hubble Space Telescope is also known as HST or simply Hubble. James Webb Space Telescope is also known as JWST or Webb. The Hubble Space Telescope is named after Edwin P. Hubble, 1889–1953, an American astronomer who played a crucial role in establishing the fields of extragalactic astronomy and observational cosmology. The James Webb Space Telescope is named after James Webb, 1906–1992, NASA's second administrator, best known for leading Apollo, a series of lunar exploration programs that landed the first humans on the moon. Webb is not a replacement for Hubble, its capabilities are not identical. Webb observes the universe in the infrared, allowing it to see through dust and gas clouds. Hubble studies it primarily at optical or visible and ultraviolet wavelengths, though it has some infrared capability. Webb also has a much bigger mirror than Hubble. This larger light collecting area means that Webb can see farther back into time than Hubble is capable of doing. Hubble is in a very close orbit around the Earth, while Webb is a million kilometers away. Launch date: Hubble, April 24, 1990. Webb, December 25, 2021. Service start: Hubble, May 20, 1990. Webb, July 12, 2022. Primary mirror diameter: Hubble, 2.4 meters. Webb, 6.5 meters. Mass: Hubble, 11,600 kilograms. Webb, 6,500 kilograms. Operating temperature: Hubble, 21 degrees Celsius. Webb, minus 220 degrees Celsius. Dimensions, length by width: Hubble, 13.1 by 4.3 meters. Webb, 21.2 by 14.2 meters. Distance from Earth: Hubble, 547 kilometers, Webb, 1.5 million kilometers. Serviceable: Hubble, yes. Webb, no. Wavelengths: Hubble, ultraviolet, visible, portion of near-infrared. Webb, near-infrared, mid-infrared. Both Hubble and Webb are reflecting telescopes. Light from distant objects enters the telescope, reflecting off of the large primary mirror, sending it to the smaller secondary mirror. The secondary mirror reflects that light back through a hole in the primary mirror where it comes to a focus and enters each of the telescope's many instruments located behind the primary mirror. Hubble Space Telescope, ray trace. James Webb Space Telescope, ray trace. Mirror size comparison of Webb and Hubble. Both Hubble and Webb use curved mirrors instead of lenses to collect and bend light to their various instruments. Despite its larger size, Webb delivers about the same resolution in near-infrared light as Hubble attains in visible light. A telescope's resolution, the amount of discernible detail, is proportional to mirror size, and inversely proportional to the wavelength of the light observed. For Webb to resolve the same level of detail at longer wavelength infrared light that Hubble achieves at visible wavelengths, its mirror needs to be proportionally wider. Hubble orbits the Earth at an altitude of about 340 miles, 547 kilometers, inclined 28.5 degrees to the equator. Webb's orbit is more than 4 times farther away from Earth than the Moon. Webb orbits the Sun with Earth, roughly 1.5 million miles away from home around the second Lagrange or L2 point. From Webb's perspective, the Sun, Earth, and Moon will always be in the same part of the sky, allowing its enormous sunshield to block their light and keep the telescope cool. The diagram below illustrates the spectrum of electromagnetic energy, highlighting the portions detected by NASA's Hubble and James Webb Space Telescopes. 90 to 2,500 nanometers. 600 to 28,500 nanometers. Hubble can observe in near-infrared light, but it was optimized for shorter ultraviolet and visible wavelengths of light, while Webb observes primarily in the infrared range. This illustration compares how far back the telescopes are able to see. Basically, Hubble can see the equivalent of toddler galaxies or young galaxies, while Webb is able to see baby galaxies or newborn galaxies. Hubble and Webb Space Telescopes.